Okay, in this video I'm going to do a basic example that uses the normal distribution table. And the point of this example is really just to get a little bit of practice with that normal distribution table and how it works. So I've already typed out the problem here, and that is that we suppose that a certain manufactured product's weight is normally distributed with a mean of 100 pounds and a standard deviation of 4 ounces. Okay, so when you manufacture an item, you have a target weight. If this item were ideally made, then it would have a certain weight, but inevitably there are very small defects that can come into that manufacturing in the item. So the weight isn't actually going to be exactly the same for each item that's produced, and usually a normal distribution is an appropriate model for the weight of the produced items. And in this situation, we're going to address what is the probability that a randomly selected item weighs no more than 100 pounds 5 ounces. Okay, so we need to define a random variable here, and x I'm going to let be the item weight. And we're told that x is normal with mean 100, and since I'm in pounds, the standard deviation is not 4, it's 4 ounces. It's 1/4 of a pound. So the standard deviation is going to be 1/4. Okay. And we want to know the probability that a randomly selected item weighs no more than 100 pounds 5 ounces. So that's going to be 105/16. Well, we know how to do this. It is the integral from, let's see, negative infinity to 105/16 of the PDF, 1 over the square root of 2 pi times sigma, that's times 1/4, times e to the negative x minus mu is 100 squared divided by 2 sigma squared. So that's 2, let's see, I want to divide by this whole thing, 2 divided by 16. 1/4 squared is 1/16, so that's why we divide by 16, and then dx. So this is what the integral would look like, and I can do this using Wolfram alpha. Okay, so we want to integrate from negative infinity to 105/16 of 1 divided by the square root of 2 pi sigma times 1/4, just means we divide by 1/4, times e to the power of negative x minus the mean is 100 squared divided by 2 divided by 16. And we're going to integrate that from x equals negative infinity to 100. And let's see, what's 5/16? I'm not really exactly sure how to enter 105/16 into Wolfram alpha without changing it to a improper fraction, so instead I'm just going to get the decimal. The decimal for 5/16 is 0.3125. Okay, so we get that this probability is about 0.8935. Now we did that using Wolfram alpha. But in practice, usually people use a normal distribution table if they don't have access to a computer. If you do have access to a computer, then there are lots of statistical packages out there, and they will do this calculation really quick for you. You don't have to go through typing in that PDF. So let's talk about how to do this calculation without Wolfram alpha. What I'm going to do is make some space here, and to do that I need to, let's see, I'll get rid of this integral, and I'm going to take this selection here and move it right there. So we already know that. You know, this probability is about 0.8935. Okay, well I'm going to introduce something called the z-score. And the z-score for a number, I'm just going to denote it number, you can put x here or a, and that is your number minus the mean divided by the standard deviation. It's the signed number of standard deviations that your number is from the mean, signed as in S-I-G-N-E-D. Okay, so for our example, we have, I don't want to put equals there because that is generally true for any number, but we have a special number. Our number is 105/16. Okay, so z sub 105/16, well, that's how many standard deviations that number is away from the mean. Okay, so we find the difference and then we divide by the standard deviation. So we get 5/16 divided by 1/4. Okay, if I divide by a fraction, I take the reciprocal and multiply. So I get 5/16 times 4. 16 and 4 cancel out and leave a 4 on the bottom, and I get 5/4. 1.25. So what I'm asked to find here is the probability that my z is less than 1.25, and that's exactly what our normal distribution table does. What I'm going to do is pull up my course web page, and the course web page might look a little bit different than it does right now, just because I'm making this video right now, and I'll probably do changes to the course web page between now and when you view this video. I'm going to go over here to this normal distribution table. And if I look at the normal distribution table, what this gives me is the probability that my random variable, my normal random variable, is less than or equal to a value x. And to do that, I compute its z-score, and then I find this z-score where the ones and the tens digit is on the left side and the hundreds digit is on the top. So we had a z of 1.25. What that means is that I go down to the 1.2 row, and I look up at 0.05, so that makes 1.25, and I find this, whoops, let's see if I can only highlight, 0.8944. 0.8944. So that's it. And we go back, and we find that this is about 0.8944. Okay, now notice these two are very close, but they didn't match up exactly. And the reason for that is both of these numbers are an approximation. The number on the z-score table, that's an approximation to the nearest 10,000th. This number was a number computed by Wolfram Alpha that was an approximation, a decimal approximation for that integral. It turns out that we cannot find a closed form exact value for these probabilities. We would either have to write it out as an integral or some other kind of, maybe an infinite series, some other kind of thing that involves a limiting process. We can't just say this is e to the sine of 5 pi over 6 square root of 2 or something like that. Instead, we have to have a decimal approximation or some kind of more complicated way of writing it that involves a limiting process. So anyway, that is how we use the normal distribution table. The normal distribution table will give us the probability that the z-score is less than that value. Now, we can use the table to deal with other kinds of situations. What if that's a greater than sign? What if that's a negative? We didn't see any negatives on our z-score table. Let me pull it back up here. Okay, there's no negatives around here. Well, it doesn't take a lot of work to be able to work with those kind of situations. So we will see that in the next video.